I like this meetup, so it's great to see so many of you coming out tonight. I will encourage you to stick your hand up, ask questions. I'll ignore them if I don't know the answer. But yeah, please speak up. I will pick on the front row because I work with these guys. So don't be shy, please. So yeah, basically, I kind of just wanted to kind of hone in on some of the things I've seen, especially recently when I've been sort of doing the hiring. I was fortunate enough to kind of be given a team that I needed to expand, which meant going and hiring. So you can either go get someone who's massively senior, loads of experience, expensive, or you can, in my preference, is kind of go the other way, where you can kind of get enthusiastic young minds who maybe don't have all the experience that kind of backs it up, but are willing to learn, will learn the good way of how to build software properly, because there's been too many things we've seen over the years that just hasn't happened. You know, there's a proper way of being able to build software, and if you can bake that in as a graduate, as a junior, as a mid-level or whatever, will set you apart. So I thought I'd kind of give you some of the things that I have tried to take pride in as I've kind of grown over the years, and what I kind of then look for when I'm hiring, and the kind of advice I would give to sort of those in uni or coming just out of it, maybe looking for your first job or whatever. So these are the kind of things I've no idea if they teach them in uni. I hope they do. If they don't, I would like to get involved with the unis and say these are the kind of things that enterprises are looking for in an interview when we're hiring, and kind of go from there. So the main sort of 4 topics, there's a few slides that might roughly fall into one of these 4 categories, but basically, you know, version control and collaboration. You won't be building things in isolation. You might have been at uni, you might have small teams at uni. The team I kind of oversee, there's 8 of us. We're part of an organization that has 50, 60. The organization as a whole that the CTO is under has 500 employees. You will be sharing your code. You will have to work with other teams. You might as well get good at it. I'm all for making my life easier, so like development environment and tools. I know I work with some engineers who will use VI, Vim, NeoVim to do other encoding with. Use an IDE, it's much easier. Code quality and validation, massively important. I know there's a few smiles in the front row from this one. Code's great. Writing code's fantastic. If it doesn't work and you can't prove that it works, it's useless. And the one that will underpin everything that you ever do, especially today if you've used any TypeScript on Node modules, there's been another supply chain attack, following up on the one from last week. I kind of wish I wasn't in the security champions group anymore, because that's all we seem to deal with just now. But it's there. You cannot be a developer, engineer of any kind of level of quality without understanding that the security kind of fundamentals have to be baked into everything that you do at all times. So yeah, without any kind of further ado, I've got lots of bullet points up here. I'm not going to go through each one of them. If there's something up there that you want to know more about, please stick your hand up. But they're very high level. Does everyone know what a pull request is? Stick your hand up if you don't. It's okay, because if you use GitLab, I believe they call it merge requests, and they used to be called change requests back in the day. It's how we get code in to the main branch or the master branch or whatever the main development branch is that you have in your repo. If you use small ones, they're much easier to review. If you're giving me a 100-file PR, it's going to take me a long time to review it, and I'll find lots of comments, questions, suggestions, etc., which means that you're then going to have 200 comments to go through, which makes it harder, longer to kind of get through. So keep it small. At least then you can kind of bundle up what you're actually doing. It makes it easier to describe what it is you're about to do, the impact that you're going to have on the code base, and any risks associated with deploying that. So therefore I would recommend, and if you don't already know what it is, conventional commits, and when you're reviewing PRs, use conventional comments. It makes you focused on what the change actually is and therefore how you can describe it. And then the conventional comments is a nice, easy, standardized kind of way for your team to basically give you feedback. Because there will be things like, I would suggest you do this, or I have a question about this bit of code, or great, that bit solves a security flaw, or whatever it is. If you have a nice, easy way of being able to do it, then the reviewee can quickly get back through the PR and make the changes or start the conversation. Because PRs and merge requests should be a learning experience. They're not a marking your homework. It should be I propose a wee change here. Is it good? Give me feedback. If you're a junior, you should be asking your seniors for feedback. These are learning experiences. They're not, I'm scared to put a bit of code in. This is how we learn. This is how we get better. I would also recommend, and it's not on the slides, but contribute to an open source project. I still get imposter syndrome now when I make a change and propose a change into quite popular repos, because you're going to get a lot of eyes on it. You're going to get a lot of feedback, but it makes you better. It generally does. Just makes you think what you're actually doing, why you're doing it, and how you're doing it. And if you're doing that, then you're already head and shoulders above 50% of the developers out there. You also realize I just threw out, percentages for fun, at least 75% of the time. So yeah, semantic versioning, does everyone know what that is? It's okay if you don't. Some of us like to just pick random versions at will when we make a change. Is it a V1? Is it a 0.01? We can build tools that then tell us if things are patches, which are fixes, they should be safe to merge in without any breaking changes. But as soon as you pull in a package or a module or whatever that then breaks your builds, destroys your Fridays because they should have been marked as a breaking change when they're not, or vice versa, then you'll love semantic versioning because it's objective and unemotional. And it just gives you a little bit more idea of what it is you're pulling in. Again, going back to the Node or TypeScript or Go or C++, whatever it is, there will be modules that you're pulling in. You need to, you don't write all the code yourself. You kind of stand on the shoulders of giants. So therefore, you need to know what you're pulling into your code base. And one of the ways is proper commits, semantic versioning, etc. Like I say, pick an IDE, IntelliJ and VS Code are the two popular ones right now. We might see a third one pop up in 20-30 minutes or so, but right now I've not got an invite for it yet, so I'm going to stick to use IntelliJ or VS Code. That's what most of the developers I'm aware of will use. I don't really care which one you use as long as it helps you get your work done efficiently, properly. You can pull in the plugins to do linting, pre-commit hooks, or these kind of things. When it comes to debugging and fixing things, who's used Postman to do API testing? Anyone else use any other tools for API testing? Yeah, Swagger? Yeah, so it's the same idea. Basically, we want a nice, easy, shareable way of being able to kind of go and test your APIs. I put a meme up there, but yeah, actually print lines work really well some of the time. You can't leave them in, so it then kind of becomes logged. But yeah, being able to kind of test your API in isolation. So if you're mobile developers, web developers, whatever kind of developers you are, you need to be able to know that your API is operating normally, so that when your app doesn't work, you can kind of filter down what the problem area is, at least a little bit. So yeah, Postman's good, but it does have a license, so find a company to pay for it for you, is what I recommend. Bash, use shell scripting, get good with CLIs. If you're on Azure, it'll be AZ. If you're on AWS, it'll be AWS. I assume Google's got another one as well. Whatever your stack is that you're using, get used to it. Every machine pretty much on the planet will have some sort of terminal shell that you can use. They're all compatible with it. JQ is probably my most used sort of CLI after the kind of ones that we're pulling data from. And that just allows me to do some JSON parsing on the terminal, which pretty much every sort of output, so if you're using Postman, Swagger, whatever, you're going to be likely getting JSON responses. You can then pass it with JQ, format it, find data in it, and then use it from there. And get good at scripting, because it's not going away. Even if you don't move into DevOps or whatever, get good with nice little scripts on the terminal, and you'll be, well, it looks cool as well, to be fair, when you're just kind of bashing out code. So yeah, I would recommend getting good with those 3 sort of 4 technologies there. And I don't know if I can get rid of the bit at the bottom. No. The amount of times I have heard that it works on my machine, which is great if all your customers are going through your machine, but generally they're not. And this is the one question I really wanted to ask. For those at uni, how much Dockerization or containerization do you actually do? And none might be the answer, which I was a little bit concerned about, but if you can Dockerize an application, it will run everywhere and anywhere. You don't have to worry about dependencies on your machine. It doesn't matter if it's a Windows machine or Linux or a Mac, it will run if you can Dockerize it. That's my one tip for just now. Get good at being able to Dockerize an application, especially if a lot of junior developers will kind of move into a company and it'll be legacy software that you have to look after. If you can Dockerize it, then you can test it, and if you can test it, you can fix it. I wouldn't want to be testing and fixing any legacy code without being able to know a baseline. And I have horror stories to tell you, but that's for the break and afterwards. And if you can containerize it, you can test it locally. And if you can test it locally, you can build it locally. And if you can build it locally, you're not going to be bringing down prod on a Friday afternoon. Or deleting namespaces and staging. Because there is no place like home. So yeah, if you can, I would rate it's the feedback loop is so much smaller and shorter if you are being able to test locally. Even if you have a push up and it's taking a minute or two to deploy, that's another minute that you have to wait for the next fix to go up. So get good at testing locally, and get good at pipelines. Your code, you should never, ever, and I'm hammering this home, never ever build from your local machine and push to a production environment, because I guarantee something will go wrong. Humans are terrible for typos, so therefore remove the human from the loop, get a nice pipeline, use Jenkins, TeamCity, GitHub Actions, GitLab CI. Doesn't matter what it is, we can all wrangle YAML together. And get some documentation, keep it good. If you're kind of moving into a new team, the first question we'll ask is, how does it work? What do I need to look for? You'll be told to go and look at some documentation. I guarantee you look at the documentation and realize it's not there. It'll be a broken link. Read it, fix it, push it back. That'll be your first PR. You can get that done by the first afternoon that you start in the team. As Ben will know. It's a lot of do as I say, not as I do at times. I'm getting better, I promise. And this is another one. This is a nice wee segue. Oops, too many. Since you all saw that, whose job is it in a team to look after the code quality? And it's everybody's. And if anyone tells you otherwise, they're lying or they're not very good at it. This is where the team ownership come in. I guarantee if you feel that you own the code, you will want to make it better. And if you want to make it better, you do not want to be woken up at 3 o'clock in the morning on a Saturday or a Sunday to try to go and fix your code. Because A, the people that are phoning you will not be happy, and then on Monday you'll need to deal with it even more at the higher level when the managers come back in going, why did you wake me up at 3 o'clock in the morning to go and fix whatever it was that broke? So it's everyone's responsibility, especially as a graduate. You'll have fresh eyes, you'll have questions that you won't know all the answers to or think you know all the answers to, which is good, because you'll go, why does it do that? Why does it do the other thing? And then, as we were chatting beforehand, rubber ducking development is when you basically just speak to a rubber duck or a dog or a inanimate object. And as the art of speaking it out will then tell you what you've missed and improvements to make. Has everyone heard of the test pyramid when it comes to unit testing, end-to-end testing, integration testing? That's fine. Basically, if we start from the bottom layer, you'll have more unit tests for a bit of code than you will any other type of tests. These are perfect for logic tests, function tests. It's basically you want to test everything in isolation. You have complete control over the code base. You'll be mocking out everything it connects to. So you'll have lots of these. They should run really fast, and they'll be the first indication of good quality code. The next layer up is when you combine all your units, systems, whatever you want to call it, together. Some of these are called service tests, integration tests, function tests, depends what terminology your team is. It comes back to the documentation, ask, get the terminology down so you all understand what you're actually talking about on a day-to-day, week-to-week, sprint-to-sprint basis. This is when you start hooking things up. This is when you should be testing your components in isolation without the rest of the code base. So these things would be like your API. You've not got your UI on there yet, or your UI is getting tested in isolation without the API. So you'll be mocking out the API, or you'll be just using JQ or whatever to test your outputs from your APIs. And then at the very high level, the top one, which is the slowest to run, and these are the ones we're trying to mimic what the user might do. And these are UI, end-to-end, or full system integration tests, again, depending on the terminology that your team or your company uses. These are slow, expensive to write, to maintain, but they try and mimic what the user will do. And any good quality engineer will tell you that users are crazy and will try the darndest of things. So that's why they're expensive. They're a bit flaky at times, but they usually will kind of give you a little bit more to kind of allow you to validate things. So this is all testing does. If you could guarantee that your code would run perfectly every single time, you wouldn't do any tests, but no one can guarantee that. So these tests are important because they catch and they validate our changes. Some tools that you might come across, SonarQube, Sonar Cloud, basic static analysis tools. So they will look at your code and complain that it's not good enough. You can then decide as a team what is good enough, and you take a pragmatic approach to it. You will never ever reach 100% test coverage. Any manager lead that tells you you can, you cannot, not for any length of time anyway. So pick a coverage level if that's what you're measuring it on, and try and cover the bases basically. And then just make sure that you can move fast with your code base, scale it so that you can have multiple people working on it at any given time to fix those gaps. The fun bit. Again, it's everybody's job to care about security. Again, it's not the security engineer, it's not the QE, it's not the manager, it's no one person's job, it's everyone's, because any weak link in the kind of code base, the deployments, the testing, the access, the IAM rules, anything like that, that's where it will come in. I think the biggest concerns right now is actually phishing attempts. You'll get an email, you'll click on it, He'll install something malicious, he'll steal your creds, and then someone logs in as you. Because we can make the most robust, secure systems out there, but if you give away your password accidentally, or your 2FA code accidentally, it doesn't really matter. That's how they're getting in. And yeah, has everyone heard of OWASP? It's not the be end and end all, because there's more than 10 issues, but it's a good place to start. The main thing, again, as I was kind of mentioning about kind of docs, you want to kind of go in with an inquisitive mind. Ask why. Why do we do that? Why have we hard-coded that? Where do I get the secrets from? Where do I get the access keys? Should that API key be there? Why is that the same one as in prod as in dev? You know, these are the kind of questions that you can ask, especially if you're young and you're just kind of in the door. I use it as a manager just now. I can get away with just asking daft questions because I'm just in the door. Take advantage of that. Use your naive approach, or whatever you want to call it, as a why. Keep asking why until someone either says, here's the manual, or we didn't think of that, that's a hole, thank you very much. Do you want to go and fix it? So yeah, use that to your advantage. All the kind of other things I've kind of got there, I'm basically just going to pull out principle of least privilege. Does everyone know what that means? Again, it's okay if you don't, but basically it means that when you give access to anything, because, can anyone tell me what the most secure system ever would be? This is a trick question.
Offline system?
No, it's a system that has no access at all. You cannot see it, cannot get into it. It's the most secure. The least usable, it's pointless, but it's mega secure. So if we want to be able to use a system, you have to be able to get into it. So therefore, the principle of least privilege means I'm only going to open up that little bit of your door with just the minimum amount of privileges or permissions that whatever action you're trying to do needs. So I know AWS with IAM was confusing, it was hard to do. So many tutorials out there would just go star for the resources and actions, which basically means everything to anyone. That's bad. That's like the opposite of least privilege. So with the advent of kind of Terraform, CloudFormation, Pulumi, etc., these kind of tools, you can now kind of get really narrowed, scoped permissions. Take the time to kind of get good at it, and then even if you do suffer a breach, the blast radius will be as contained as possible because the permissions that were stolen only had a limited set of things that they could do. And if it's a read-only one, then they cannot change anything, they can't mutate anything, they can't, ransomware anything, they can't encrypt anything. So quite important, hard to do at times. But that's, again, if you're just kind of going into the job, going into a career, going into a new company, there should be seniors, there should be leads that will guide you on that front. And yeah, I know I looked at these GIFs of mainly for me. They can sail over everyone's heads. I don't care. They made me laugh. So the last one I thought I'd kind of give, and this was ideally a little bit of kind of feedback here. Who's going to be looking for a job or looking to get hired in sort of the next, I don't know, year or two? What are you most worried about when it comes to the interviews, and what are you hoping to kind of get from them? And it's a deliberately wide question, so.
Legal.
Yeah? Great if you want to go and work for a FANG company. How many of you guys have done leak code interviews at Enable?
I'm not an Enable.
Dan, how many interviews in leak code have you done?
No.
Yeah. Folk ask for it. Technical interviews will ask for it. I'm not entirely sure why at times. But yeah, Nico?
Actually, speaking of leak code, for those of you guys who are from St Andrews, we have Society for improving people's leak code skills for interviews. So if anyone is interested, it's called Algorithms.
No, it's the good tools, good practices to have. The problem a lot of the time is they're not really representative of what we actually do on a day-to-day basis, which is fine because every company, every team will be different. So I wouldn't focus all my efforts on leak code, but if that's what the interview says, and this is again, it's a question, a lot of the kind of good things is preparation. So if you prepared for whatever's about to come, like tonight, I had to present and prepare a presentation and do a bit of practice on it. Same with interviews. Ask what the interviewers are looking for. If all they want to do is a whiteboard exercise, then get really good at trying to memorize bubble sort, binary searches, all that kind of stuff. That's what they'll ask for. If it's leak code, get really good at leak code. If they want you to do an interpretive dance, then get some nice shoes. You know, it's all about getting your foot in the door. And if that's what the interviewers are looking for, I don't know how it helps with the job, but if it gets you the role, and then you can kind of grow and learn from there, because it's experience after that. You know, you go to school, you get some standard grades or whatever they're called, these GCSEs, whatever they're called these days, show my age, and then you get your hires, and then you go to uni, and then you get a job, and then you get the experience, and then you get the next roles. So just get your foot in the door. Actually, and you go.
I believe the fundamentals of system design are really important. Like even leak code is like, you know, if you practice it enough, you'll eventually know the algorithms and you know the pattern structures. But system design, core concepts, they're very important.
All of this, basically, if you could learn all of software, architecture, engineering, computer science, you'd be great. There's just too much to learn. So, I'm not going to pretend that trying to get hired is easy these days. I read all the articles that you guys do. It has to be tailored. Like if I'm interviewing you, it's time consuming. I'm needing you to do a particular role, job, thing in my team. Therefore, my questions, my kind of probing of your knowledge, etc., will be totally geared towards that. And I guarantee if you went to talk to another hiring manager, even another team or another company, questions might be completely different. So I don't envy you at all, which is why I kind of wanted to kind of share some of the things I look for when I'm looking to hire and whatnot. So
also like good practices as well, like in terms of if you go see any bootcamp or a course online, if they're like initiating a database connection, mostly they don't use it they don't use the factory design pattern to initiate it once. So this experience you only get it on site, and then you can't get on site until you get this experience.
It's a horrible catch-22. It's always been a little bit like that. It kind of goes through peaks and troughs. Yeah. I'd imagine if you try to get a job in the dot-com bust of like early 2000s, it'd have been a nightmare. 2008, 2009 would have been difficult as well. The kind of basics of like software engineering don't change. Like say, test, develop properly, collaborate with your team. These things never change. The kind of skills that people might probe you during interviews or technical prep, that kind of stuff changes. One of the things that we like to do when we get the kind of time and looking for new hires is to basically bring them in, and it's technically a whiteboard exercise, but I'm going to give you a set of problems, set of priorities, a set of tasks that the company want. Which ones would you do first? And there might be an optimal order, there might not. It's the questions. I want you to ask the team questions, because if you get hired, you're going to be part of 1 of 5, 1 of 8, 1 of 10. And you spend a lot of time together. So those are the kind of things I look for. I can teach you syntax, I can teach you whatever language it is. We use Golang, and it's Kubernetes, and we're built on AWS. If I need to, I'll send you to an AWS conference course. I can teach you Golang. It's syntax is text in the end of the day. If you know what to write, I'll show you how to write it. It's easy that way. Hopefully, Ben. Is that true? Getting there. That's why I've delegated to the leads. The kind of bullet points on the left, those are the kind of things that you should be asking. And see if you don't get the answers that you like, trust your gut. if you're coming in as a junior and you ask about career progression and they can't give you an answer, question it. Like I said, get your foot in the door if you need to kind of just, get some money, get some experience. It'll make it easier for jumping to the next course. But you should have a clear career progression of at least where you should be going. A kind of good mentor will not only guide you through the company, but will guide you through your career. So I can kind of basically tell anyone what the kind of levels you should be aiming for. What does a senior look like? What does a staff engineer look like? What does a principal? And then we'll get to that level. Do you go into management or do you stay as an individual contributor? These are questions that you have to answer on your own, but they're important to kind of ask in the interviews, because if you get a good answer, you'll get a kind of good feeling that they will look after you. Same with a kind of team composition. Is the entire team made up of seniors, or are they all junior? Brain drain is a problem. I had a couple of companies early on in my career when I was juniorish level, been there 1 year and then 2 years, and there was redundancies right across the board. All the seniors left, and suddenly I'm one of the most experienced people there. That's no good for my career. The code base isn't going to be great for that. You're kind of left with this legacy code base that you're meant to look after, and that's not great. So team composition, quite important. You should have a mentor, you should have a buddy, you should have ideally someone at the same level as you, so you can learn together, compete together if that's your thing, but you kind of drive on and be better together. And then if all goes well, you get hired. Dead easy. I wish. And I try to kind of condense everything down into one quote. This is actually original, if Claude wrote it anyway. But be curious, be humble, and be relentless. We will never know everything, therefore always learn, ask, lean on the kind of people around you. Come to things like this, it's great. Be humble though when someone points out that you might not have the correct approach, but again, you can be curious about why you might not have the right approach, and just never stop learning and practicing and being better. I hope the day when I can't be bothered anymore is the day I retire, I'll be totally honest. I love the software industry. I love software engineering. I love building things. I built Lego when I was a kid, and now I just build systems. And now I've got teams that I can build, and the teams can build software. It's exciting. It really, really, really is. So those who are looking for hiring, finishing uni, started the first job or whatever, have fun, good luck. I wish you all the best. So that's everything from me tonight. Yep.